Okay, here we go. This is Unit 1, Lines and Angles, Lesson 1, Basic Terms and Constructions. Our first definition for geometry is point. You've probably seen this before. A point is a location in space without any dimension. So this is an example of a point. It is point A. This is how you would draw point A. You see the point is a dot and A is written with a capital letter. Now if you were writing about point A, you would write like this. This would be point A. So again, a capital letter for point A. Next up we have line. So a line extends infinitely in one dimension. So that would be side to side here. You could have up and down, diagonal, one dimension though. And that is 2 points, such as A and B, and all the points between them and beyond them. These arrows show the beyond. And this is how you would draw a line AB. If you were to write it, you would write AB, capital letters again, because they are points. But then you would draw this line over it with the arrows. Those arrows are important. So you could name a line with points. You could also name it, if you had like a little cursive letter here on the line, it's not attached to a point, that is the name of the line. So you could name this line L, and those are both acceptable ways to name the line. Next we have plane. So this is a plane extends infinitely in 2 dimensions. So you see that is represented by this parallelogram here with the borders. So it is a flat surface, and you see within it the 3 points. You do need at least 3 points to name a plane. So this would be plane ABC. And just like above where we named that line, line L, if you had another letter in the corner here, this would usually be a capital letter, usually, but it's not attached to a point, then you could name this plane M here. Okay, so, and an example of a plane would be like a sheet of paper. So you have that flat surface, but really the sheet doesn't have any width to it. Then a line would be like the edge of a sheet of paper, and a point would just be like if you made a mark with your pen or pencil, like that. Okay, so these 3 terms, point, line, and plane, are known as the undefined terms of geometry. So it is said that these are described, not defined. And that is because the definitions for these are so vague and general that they're not said to really be definitions. So let's see if we can't identify point, line, and plane in our first example here. You see our diagram, and we want to name the points, all of the points that are shown in the diagram above. Now remember, points are named with capital letters, and they have points drawn next to them. So I see points at L, N, O, M, and P. So K is a capital letter, but it doesn't have that point next to it, so that is not a point. So we're just going to write all these down. L, N, O, M, and P, and that is all of them. Okay, that's pretty simple. Next, let's name the lines shown in the diagram above. Okay, so remember, lines, we need 2 points to name a line. And I see one line here and one here. They also have the arrows on the ends of them. These are not lines, those are the boundaries of the plane. so that's not a line. This first one here, I see L and N and O are all on that first line. And I could use any combination of those two to name the line. So for instance, I could say this is line LN. I could also say it's NL, doesn't matter which direction. LO, OL, NO, or ON. So that is all 6 combinations, but I'm only going to write one of them. So line LN. But we could also name it based on this lowercase letter that is attached to the line. So this could also be line J. Those refer to the same line. But there was that second line, so let's look and see what we have here. So I see P and N are on this line. So this could be line PN. I could have also said NP if you prefer that. And the lowercase letter attached to that line is H. So I could also name this line H. Okay, last question for example 1. Name the plane shown in the diagram above. So to name a plane, you do need, if you're going to use points, you need 3 points that are on the plane. So this blue box represents the plane. I could choose any of these 4 points, but I need 3 of them, only 3. So L, N, O, or M. I'm just going to call it plane LNO because I've already circled those. So this is going to be plane LNO. You could name it MNO, NOM, any combination, any order. But we also have this letter up here in the corner, so we could also name this plane K. So I'm going to go ahead and write that also. Okay, so plane K. Those are both fine. All right. So next up, we have these new words for you: collinear and coplanar points. So this prefix co means with or together. So really, if you have collinear, you see the word line here. Collinear points, those are points that lie on the same line. And then we have coplanar, so plane, coplanar points are points that lie on the same plane. In this example 2, you have the same diagram as example 1. We want to find 4 points that are coplanar. So remember, if they're on the same plane, plane K, then you have them all within this blue box. So I see L, N, O, and M. L, N, O, and M are coplanar. They're just looking for the 4 points in the box. Then you want 4 points that are not coplanar. So really the only point in this diagram that is not on plane K is point P. So if we put together any combination of points, as long as point P is included, then you have 4 non-coplanar points. Again, you just want to have 1 point. You could have more than 1, but you need at least 1 point that is not in the plane that is drawn, so not in this blue box, and that is point P. Last, we want 3 points that are collinear. So remember, collinear means on the same line. If we look up here, we can't use this line because there are only 2 points shown on the line. This vertical line, however, has points L, N, and O, all on that line. So L, N, and O are all on the same line. They are collinear. Next up, we have the word intersection. An intersection is the set of points that the figures have in common. So right here you just have 2 crisscross lines, which is pretty common.
Mr. Gonzalez, please call extension 223.
And they intersect at this
Mr.
point
Gonzalez,
right here. So this is our point of
223.
intersection at the star. It is 1 point. So an intersection could be 1 point, it could be many points. In our next figure, you see a black line with this red figure over it, and we'll talk about what that's called in just a minute. But you see that they overlap starting at this point and everywhere beyond it because of these arrows here. So arrows. So this entire red section is the point of intersection. So all of this is a point of intersection. Last, we have these 2 planes. Each of these is a plane. And you see their point of intersection is really a line. So these will continue along this line. But anywhere that those 2 planes touch, which is on the line, is where they intersect. So 2 planes intersect at a line.